Dear students, Namaste. I'm in complex number. This is part 3 of real number system. So I want to start the complex number definition. How can you uh, write down complex number? So for this, I want to share my uh, slide. Now for this one, complex number. Uh, First of all, how can you express such word? So it is some concept. I want to start from here. You have x square is equal to 4. X square is equal to 4. Then you can write down x is equal to plus minus 2. You know this one. So you know one concept. If you have only positive number, then you can find out is square root, and is square root is plus minus 2. If you have here is 9 plus minus 3, here is 16, you can write down plus minus 4 like this way. You can write down your root as a positive and negative. Yeah. Then after, but I want to connect here. If you have x square is equal to minus 1, how can you write down this one? Then you can write down here root under. Yes, sure. Then after, what is the value of this one? You don't know. Up to here, you don't know. Now I want to share. Now you can express is as it is 1 into minus root under 1. So minus root under 1 is we have no values. We don't know the value of this one, so we can assume that is some number. So you should here assume, or you can imagine here this minus 1 is any number, so you don't know, so you are going to imagine it is. So you should imaginary number, so you can suppose it is x is equal to, in the place of minus root under 1, you can write down here minus 1, where I is equal to minus root under 1, then you can write down it is 1 into root under I, sorry, minus into I, 1 into I. So I square is equal to minus 1. Don't forget here, if you suppose here I is equal to root under minus 1, then if you do squaring on both sides, you get it is I square and it is minus 1 only. So this is minus 1 is I square. Don't forget, it is your imaginary. The value of I is, it is root under minus 1, root under minus 1. So root under minus 1, so it is I square is minus 1. Don't forget this. So you can write down, therefore x is equal to I. Now your question is x square is equal to minus 1, and you have x is equal to minus x is equal to I. Now I want to give you again x square is equal to minus 9. If you have this question, then you can write down it is minus 1 into 9. Then you can separate your root. Now separate root, minus 1 root under minus 1 and into 9 root under 9. Now it is 3. So you can write down it is, this is I and it is 3. So you have 3I. Now again I want to revise this one. How can you take this concept? So x square is equal to 4. If you have x square is equal to 4, then you can write down x is equal to plus minus 2. Then if you have x square is equal to minus 1, then you can write down it is x is equal to root under minus 1, but we don't know the value of this one, so we are going to imagine some number. So for this one, you can write down 1 into root under minus 1. So now you can assume that it is minus 1 root under minus 1 is I. If you imagine minus root under 1 is I, then you can write down I square is equal to minus 1. Don't forget this one. Now it is 1 and root under 1 is minus 1 is I. Now it is x is equal to I. Then if you do squaring on both sides, you got x square, it is minus I square here. Now minus I square is equal to minus 1. You got this one? Yeah. Again, x square is equal to minus 9. If you have, then you can write down is minus 1 into 9. Now it is separate this one, root minus 1 root under and 9. 9 is root under 9 is 3 and it is I. So x is equal to 3I. This is your simple concept, and try to take the basic concept of this imaginary concept. Now I want to define complex number. For this complex number, I want to write down like this way. any number which is in the form of a square, sorry, a plus ib. I want to mention, yeah, any number which is in the form of a plus ib where a and b are real numbers and I is equal to minus 1, I is equal to minus 1 is known as complex number. Yeah, don't forget, you should have a plus ib form. A number which is in the form of a plus ib, a is a real number, b is a real number, I is your imaginary, so it is a real part, it is imaginary part. Don't forget, first is a real part, a is a real part, second is imaginary part, and but a and b both are your real numbers, but I is your imaginary number, so you can say the second part is imaginary part. And a plus ib is also written as in the form of a comma b in the sense of complex number, okay, not others, it is in the sense of complex number. You can write down a comma b. Now, a complex number is generally denoted by J. Here, A is known as a real part and B it is your imaginary part. IB is your imaginary part of J. For example, 5 plus 3i, it is your complex number. So here is real part, imaginary part. Minus 9 and 7i, so it is your real part and it is your imaginary part. Then if you have only 2i, so it is also complex number. So it is, you can write down 0 plus 2i, it is a real part, it is imaginary part. So you can write down your whole all numbers in the form of complex numbers. So you can sum them as real and imaginary parts. So these numbers are your complex number. So don't forget again this one. So if you can write down a number in the form of a plus ib, where a and b are real numbers, I is your imaginary, then it is your said to be complex number. After this, after the definition of complex number, I want to give another concept, the integral power of I. Now for this one, if you have I is equal to root under minus 1, then do squaring, you will get I square is equal to minus 1. Then if you have I power 3, then you can write down I power 3 is I power 2 into I power 1. It is 2 plus 1 is 3. So I square is equal to minus 1. Minus 1 into I is minus I. Don't forget here. Minus I square is minus 1. Minus 1 into I is minus I. Similarly, I power 4 is I power 2 into I power 2. I power 2 is minus 1. I power 2 is minus 1. Minus minus plus 1. Similarly, I power 21. I power 21 is I power 4 power 5. I power 4 is 1. 1 power 5 and it is I. So it is 1 power 5 is 1 and I into 1 is I. You have this concept, don't we? Afraid from these terms. Now for this one, 1 by I square is how much will be this? It is 1 by minus 1, it is minus 1. And 1 by I is equal to 1 by I into I by I. You can do this one. It is I by I square, but I square is minus 1. I by minus 1 is minus I. So like this way, you can convert all your i's, I power 5, I power 10, I power 20, I power 25, like this, all terms in the sense of I or 1. After this, what is the algebra of complex number? So you have, if you have two complex numbers, so first one is z1 is equal to a plus ib, second z2 is equal to c plus id. The two complex numbers where a, b, c, d are real numbers. Then you can do the sum of these two numbers, z1 and z2, and you can do difference, z1 minus z2. You can do product, z1 into z2. You can divide z1 by z2. So for this, then you can write down here the sum of two complex number is a complex number. If you have Z1 and Z2, if you add these two, you will get a complex number. Which number you got, that is also a complex number. Similarly, the difference of two complex number is a complex number. If you do subtract, then you will get complex number again. And number three, the product of two complex number is a complex number. If you do product of these two, you will get complex number. And the quotient of two complex number is a complex number. Then you can divide z1 by z2. This is also a complex number. So examples of these, how can you get complex number? These I want to show you the photo of these from your textbook. So your photo is this one. The sum of two complex number is a complex number. Now it is Z1 plus Z2, it is A plus IB and C plus ID. It is A plus C same, one term, and ID another term. Take common term I, B plus D. So it is capital A, it is capital B. So it is A plus IB. So it is complex number. Similarly, you can observe here difference, and it is product, and it is a quotient also. So all these are your complex number. If you do sum, if you do difference, if you do product, if you do quotient, so all these are your complex number. So you can write down this concept from here. Now today I want to do question number 6, 7, 8. So these are simple questions. So first of all, how can you convert your number in complex form? Then after these calculations. So uh, today for these three questions, okay. Okay, you can remember we have three questions like this question. Now I want to start six first number. It is your addition. Then what will be answer? Then after I will do another question, and question number IV also, and VI also I will do this one. Then question number 7 also, 8 also. Now question number 6, express the following complex number in the form of a plus iv. Your question is 8 plus 5i plus 1 minus 2i. Now separate, you can separate your bracket. Then you can write down 8 minus 5i plus 1 minus 2i. Your like term, 8 and 1 is like term, 8 plus 1 is 9, and minus 7i and 2i, it is minus 7i. You should add the same sign, which is in the form of a plus ib, where a is equal to 9 and b is equal to minus 7. So a plus ib form. So it is a complex number. So it is very simple. Similarly, it is your product, and now multiply 3 by both term. 3 times 6 minus 8i minus 2i times 6 minus 8i. Then you should multiply 3 6 are 18, 3 8 are 24i, 2i into 6 is 12i, minus minus plus 2 6 are 2 8 are 16, and I square. Then after it is 18, it is 24i, it is same, and it is minus I square is minus 1. You have this region, you have this region, and it is 18 minus, it is, you should do sum of this one. It is minus 16. 18 minus 16 is 2, and minus 36i, which is in the form of a plus ib, where a is equal to b and b is equal, a is equal to 2 and b is equal to minus 36. So this also in the form of complex number. Sum is your complex number, and product is also your complex number. After this, number iv, so it is in fraction. Now don't forget, how can you remove this fraction? So you have in denominator which term is here, so you should rationalize by that term. That means 3 plus 4i you have, then you should multiply by 3 minus 4i, 3 minus 4i. Then just remember, it is your rationalizing, okay. It is not exactly, but you can remember by that way. Now it is upper term, yeah, numerator term you should do multiply, and denominator also you should do multiply. Upper, you can multiply these two. 4 3s are 12, 4 4s are 16, 3 3s are 9. Like this way you can multiply. And down, it is a plus b, a minus b. Then you can use here a square minus b square. Here a square minus b square. You can do like this way also, or directly you can do. It is a square minus b square. And this term 12 exactly same. Minus 16 minus 9 is minus 25, and 12 I into I square, 12 I square. Now it is 12 exactly same, minus 25 I exactly same, but 12 into I square is minus 1, 12 into minus 1 is minus 12, divided by 9 minus, and 16 into minus 1 is plus 16. Then after, it is 12 minus 12, 0 minus 25i by 25. It is 25i divided by 25, it is minus I. And you can write down, it is in the form of complex. So you need it in the form of a plus ib. So 0 minus 1i. So which is in the form of a plus ib, where a is equal to 0 and b is equal to minus 1. So don't forget, it is very important concept. After this, I want to do another question. like this way. And you know how can you remove this symbol and this symbol, you know you should have root under -1 and another number, so you can break like this. So here your question: 3 minus root under 4 into root under -1, 2 plus root under -1. In the place of root under -1, you can write down I. It is 2I and it is 2 plus I. Now do rationalize. It is 3 minus 2I, 2 minus I, 2 plus I, 2 minus I. Then it is a plus b, a minus b, and you should do multiply numerator term, and it is 6 minus 3i minus 4i minus 2i square divided by 4 minus I square, and it is 6 minus 7i and minus 2. It is minus 2. How can we? 2 into -1 is -2 divided by 4 plus 1. So I square is -1, -1 minus is plus 1. So 7i, 4 minus 7i divided by 5. You can separate this. 4 by 5 minus 7 by 5 I. So it is in the form of a plus ib again. So a is equal to 4 by 5, b is equal to -7 by 5. Similarly, I want to show you another concept. It is your conjugate of a complex number. So if you have, it is a plus ib, okay, it is a plus ib. Done here, a plus ib. I want to show you it is a plus ib. So this one is um, wait for a minute. And that it is complex number, so this is integral power and algebra, and then after this one and a plus ib form, then this one and again another this, we did this also, and you have conjugate of a complex number. So let z is equal to a plus ib be a complex number, then its conjugate denoted by z bar. Don't forget, it is denoted by z bar, and z bar is equal to a minus ib, a minus ib. Which sign is here? Take just opposite of that. Here is I, in front of I. If here is plus sign, you should minus. If here is minus, you should write down here plus. In the same way, z is equal to a minus ib, then z bar is equal to a plus ib. Just opposite sign of real part. Just opposite sign of real part. It is your concept of conjugate of a complex number. Now, I want to do example. It is question number 7, z1 and z2 given. Verify. Now, it is your question. You should do z1 plus z2. You can add these two numbers, then find out conjugate. And find the conjugate of z1, conjugate of z2, then add 2, you will get same result, then you can say verified. Now check. Z1 plus Z2 is equal to 1 minus 4i plus 3 plus 2i. 1 plus 3 is 4, minus 4i plus 2i minus 2i. Then final conjugate, it is just opposite of this one. So plus 2i, 4 plus 2i. Z1 is 1 minus 4i. Conjugate is 4, 1 plus 4i. It is Z2. Z2 is 3 plus 2i. Conjugate is 3 minus 2i. Now add these two. Z1 plus Z2 both conjugate. That is 1 plus 4i plus 3 minus 2i. It is 1 plus 3 is 4, 4i minus 2i is 2i. So you got this and this result same, this and this result same. So you can write down there, we get z1 plus z2 conjugate is equal to z1 conjugate plus z2 conjugate is equal to 2 plus 4 plus 2i. Now you got z1 plus z2 conjugate is equal to z1 conjugate plus z2 conjugate. It verified. A symbol. After this, I want to do question number 8. I want to do only one question, then all the your homework, okay? Z1 is this one, Z2 is this one. 3 plus I and 4 plus 5i. Now 1 by Z1 is 1 by 3 minus I. Do rationalize by 3 plus I, 3 plus I. Upper exactly same, down a plus b, a minus b. 3 plus I by 9 plus 1, it is 10. So 3 by 10 plus 1 by 10 I. So it is in the form of a plus ib. Exactly same. This 1 by z2 is exactly same. And for next question, this one and this one, you can write down like this way. Then you got like this way. We did in question number 7 also. So this is, you can do. Okay, thank you. I did these 3 questions. If you have any questions, then you can ask me in comment. Okay, thank you.